And hello, welcome to codeLive. Thank you all for joining me today. I'm super happy and excited to be able to bring this content to you. If you have joined me in previous codeLives, you know that I am a JavaScript fan. I've been working with JavaScript since 2006. I don't know, it has been a long time. Well, I prepared something today for you. So we learn about how to perform asynchronous operations using JavaScript. Okay, let me take this off. Good. Can you all in the chat confirm if you can hear me well? And if we don't have music? If we don't have music, we should be good to go, because I was maybe having some music here, making a little bit of distraction. Mauro, yes, this video will be uploaded later after pretty much we finalize this session. This video is going to be available in YouTube. Awesome. Thank you, Ravi, for confirming. Okay. So as I mentioned, we will be taking a look at how to perform asynchronous operations with JavaScript. JavaScript is an asynchronous language by nature. It's the language of the web. Every JavaScript we execute is going to be executed on the browser. So the browser has a JavaScript engine that it's the one taking care of executing all of that code. Depending on the browser we are using, we have different engines. Chrome, Edge uses V8, which is the JavaScript engine for Chrome or Chromium. Safari uses WebKit, etc. So there are like different engines that process the JavaScript. All of these asynchronous operations are handled by the event loop. What does this mean? Well, JavaScript is a single-threaded language. We only have one thread. In one thread, we manage all of the different operations of our page, like rendering, fetching data, interaction with the UI. All of those operations are handled by just one single thread. We can have like some sort of multi-threading by using workers, but we are not going to get there yet. How can I manage asynchronous operations with one single thread by using an event loop? What is this event loop? Pretty much every asynchronous operation that I will try to do with JavaScript is going to get scheduled or queued, and JavaScript is constantly going and checking if there is a new operation that needs to be executed. This operation then is scheduled depending on the type of operation it's going to do. If it is I/O, for example, accessing network or performing an HTTP request, it's going to schedule that to the proper part of the engine that manages that. And when that asynchronous operation finalizes, it will emit an event. This is why it's called an event loop. And in the next loop, in the next iteration of that loop, if that event has been finalized or fulfilled, we can return the value to the caller, to the person that, or to the code that is calling that specific function or that specific method. So it's very important to learn how to manage asynchronous operations with JavaScript. In the past, things were very hard. We lacked a standard to manage asynchronous operations. So we relied on libraries. For example, do you remember jQuery or MuTools? These libraries gave us ways to manage these asynchronous operations by using deferreds or by using early implementation of promises. But I will not say recently because this happened like some time ago, but still for some people feels new. The standardization committee of JavaScript standardized promises. So promises are now a web standard, and you can find the same implementation of promises in all of the different JavaScript runtimes. In the browser, and also in Node.js. We have seen examples using Node.js. It uses the same JavaScript engine that we use in Chrome, which is V8, and pretty much the same operations can be done there. So today we are going to learn about promises, how to work with promises, how to create a promise, how to wrap an asynchronous operation within a promise, how to fulfill a promise, how to catch and manage error with promises. And also, in recent versions of JavaScript, there is this new syntax called async await. So it's a better way to handle asynchronous operations or operations that are promise-based on a more intuitive manner. So we will see those two examples, how to work with promises, how to work with async await. But the promise API also gives us methods to work with concurrency. So I can perform multiple parallel operations at the same time, or I can perform iterations. So it gave us ways to be better with these multiple asynchronous operations, and there are like some best practices that we are going to follow to make our applications faster. My name is Julian Duque. I'm a principal developer advocate here at Salesforce, and join me today learning about asynchronous JavaScript. So let me go to my screen right now. Remember, go to the developer.salesforce.com website. Here is the place where you are going to find the recent articles that we publish, videos, podcasts, and events that are happening in the Salesforce developer ecosystem. TDX is right around the corner. In less than 2 weeks, we are going to have TDX in San Francisco, and some of that content is also going to be streamed on Salesforce Plus. Make sure to register on Salesforce Plus. It's free if you are not going to attend to TDX in person, but if you have the option to go to San Francisco and attend TDX in person, I will see you there. Please, if you see me on the ground, say hi. I will be hanging around on the Customer 360 area, and you might see me maybe doing things. I don't want to spoil you, but I will be also giving some talks and interacting with the developer community. Okay. What are we going to do today? I already created a Lightning Web Component interface to start learning about these asynchronous operations. The first thing we are going to learn is, well, this is not part of the JavaScript standard, but you are going to find these methods on every JavaScript runtime. The set timeout and set interval. These are what they are considered the timers, and the timers are asynchronous operations. So we are going to see how can we use these timers to perform a couple of asynchronous operations. Pretty much this timer is going to receive a callback. What is a callback? A callback is a function that is going to be executed after certain asynchronous operation happens. In Node.js world, callbacks were pretty common initially. Right now, everything has been migrating to promises, but you are going to find some libraries and APIs that still uses callbacks. Pretty much, I have an asynchronous operation. After that asynchronous operation executes, I run a function. Callbacks are sometimes difficult to handle because it doesn't let me to have like a proper execution flow, since I am going away from the main context to execute that function and perform a other operation. But we are going to be using callbacks for these two tasks: set timeout and set interval. Then we are going to learn about promises and async await by implementing an API call. Remember that we recently learned about fetch, how to perform HTTP calls using the JavaScript client fetch. Well, we are going to be using fetch and performing these operations both using promises and using async await. So we will see how to convert from promises to async await, how to wrap a promise, how to create a promise from scratch, so we can load a list of movies. So we have an API. This API is deployed to Heroku. I created like a quick API that returns JSON data. And I registered this API as a remote site on my Salesforce org, so I can easily perform the fetch request, as we learned in previous codeLives. And last but not least, we have this other tab, which is cars. So I have two different APIs here. I have the cars API, which gives me a list of 100 cars. And I have another one, which is cars large, which gives me a larger data set, which are going to be 1,000 cars. We will perform concurrent operations to these two APIs to prove a point, to see which one is faster than the other, what happens if one of those fail, etc. I also added some crazy variable here. For example, boom. If I pass a parameter boom to this API, it will crash. It will return an error. So what happens if there is an error? How are we going to handle those errors? By using asynchronous operations. Bear with me. This is everything we are going to cover today. Let's hope time help us. Okay, I'm going to the chat before I start to see if there is any question. No music, clear, awesome. Thank you very much for letting me know. Amazing. I love how can we work together on this. So what we have here in this interface, we will demonstrate set timeout and set interval. Set timeout is going to execute a function, a callback function, after certain amount of time has passed. In this case, the time is set in milliseconds. This time, to be totally honest with you, is not exactly 2000 milliseconds. It might be 1 or 2 milliseconds less or more, depending of how the event loop is performing, of if it has a lot of tasks. But it is good enough. If you need like precisely real-time delays, maybe JavaScript is not going to be the language for doing that, or you will require a real-time operating system. But for purposes of this and most of the use cases, this is good. So after 2 seconds pass, I'm going to show a message. Right now, it doesn't work because we don't have any implementation. And what is set interval? Set interval is going to execute the same function every certain amount of time until I decided to stop. This is going to be like a repetition of executing the same task until I decide to stop that operation. Luis asked, are promises applicable in Node.js? Yes. Every JavaScript runtime supports promises. Node.js, Dino, Bon, SpiderMonkey, all of them. So the same things you are going to learn today are applicable to Node.js. But I prefer to use this Lightning Web Components example, so it's more visual. Let's go to the code. I have Visual Studio Code here with my project. So this is a Salesforce project. I have the application container. Application container pretty much has 3 components: the timers tab, the movies tab, and the cars tab. That's it. And let's start with the timers tab. So the timers tab, which is this interface, has 2 inputs and 3 buttons. Let's focus on set timeout. Let's just implement set timeout before going to show message. So I am not going to be doing all of the Lightning Web Component implementation on the front end. I already have these interfaces created. I will explain what I did. I will focus on the JavaScript because we are learning JavaScript today. So the first line in input that I have, it specifies the timeout millisecond value. So I'm wiring this up to the timeout time. This is a variable that I have on my Lightning Web component. And I have a method that is going to update that value on my component. So if we open this JavaScript, we'll see timeout time, and it starts on 2000, like 2 seconds. But the methods that are going to perform the operations are empty, so we will need to implement those. What I have implemented already are getting the value of the timeout input and a method called showToast. ShowToast pretty much is going to show a toast in my interface after the timeout has been executed. So my task right now is use setTimeout to show this toast. Perfect. So the button has a variable here called isWaiting, so I can disable and enable the button while I'm waiting. You can use a spinner, you can use any other type of visual aid to help people know that there is some asynchronous operation happening. And when I click the button, I will start that timeout. Okay? Perfect. So let's implement the start timeout. So start timeout, we will use the method setTimeout. And the method setTimeout receives 2 parameters. One parameter is the function, and one parameter is the time in milliseconds. So the time is going to be this timeout time. And the function, we are going to use an anonymous function, and I will show you why anonymous function. I will use an anonymous function, especially an arrow function, that it will be executed after the timeout happens. So I'm using an arrow function. Why an arrow function? Because I need to have access to certain variables and methods that are on my class. So I will use this keyword. In this case, after the setTimeout happens, I will execute showToast. When I'm using an arrow function, the this keyword is the same this as the pretty much the context or the parent context where I am executing the method. So this pretty much has a reference of the instance of the class or the object or the function. So right now, this reference belongs to the parent. If I have a function here, instead of an arrow function, this keyword belongs to the context of this function, so it will fail. First lesson that we need to learn is when we are using setTimeout and we need to access the parent context, we use arrow functions. You might have seen certain JavaScript code that does something like this. Self equal this. It's stored in the context in a variable so I can use it internally. Don't do this. This is all the JavaScript. These are tricks that we did back in the day. Now, since we are using arrow functions, that has been solved. And what else do we need to do here is changing the waiting variable. So right now, I am waiting until the time passes. When my method executes, I will set waiting to false. So the button gets enabled again. Julian, I ask myself, why you are adding the is waiting inside the method or inside this function and not outside? Because if I read this, I am waiting, I am executing a function, and then I am setting a variable. No. Why? Because setTimeout is an asynchronous function. This is going to be a schedule on the event loop, and the next line is going to get executed immediately. So the order in this case is going to be is waiting true, is waiting false, and after 2 seconds, show toast. So we don't want that. We want to change the variable after we show the message. So after the asynchronous operation is completed. This is why it's very important to differentiate between synchronous or blocking operations and asynchronous operations. In this case, set timeout is an asynchronous operation, which doesn't block the event loop, which is going to schedule the task, and I will need to perform this operation. Questions so far? I know it is a lot, but questions so far? Please zoom your screen. Your wish, my command. Let me transition so you only see my screen, and I will not be doing faces. And let me know if this is better or if you need some more zoom, sort of. Okay, let's hope this is better. If not, I will zoom more. And I think I can zoom a little bit more. Yes, let's hide this. And so far we don't need this. Yes. So this is the start timeout method. I have the set timeout. I execute this function after a certain amount of time passes. It's better. Awesome. Fantastic. Thank you very much for confirming. Let's deploy. So I'm going to deploy this new Lightning Web component to my Scratch org, and let's see how it works. Or if it works. Let's hope we don't have any issue. And please feel free. I'm always monitoring the chat. If you have any question, if you need more Zoom, or if there is a topic or a concept that is getting a little bit tricky, let me know. I will be more than happy to stop and explain, because that's the idea. We're learning. Cool. Refresh and see if these work. So now if I click on show message, after 2 seconds, something needs to happen. 1, 2, and it worked. I appeared after 2000 milliseconds. And you see that the button had this transition. If I increase the time, 1, 2, 3, 4, 5, and it will appear. 5,000 milliseconds. So this is working as we expect. It can be less time, 50 milliseconds. This is going to be pretty much almost automatically. So now we learn how to perform these timeout operations. Let's go to interval. Interval is also an asynchronous operation. It works pretty similar to set timeout. I have a function that is going to be executed inside the set interval, but that function is going to be executed always, every certain amount of time. Let's go to the code. Let's go to set interval, specify the set interval function. It receives as the first argument the function that is going to be executed, and as the second argument, the time. In this case, it will be interval time. Same rules as before. We will use an asynchronous, a arrow function, so we can have access to this. And what are we doing here? We have a counter. Yes, we have a counter, so we want to increase the counter every second, every pretty much 1,000 milliseconds. So let's increase that counter. Counter is a variable that is on my class. Fantastic. But how can I stop the timer? I can start the timer, but how can I stop it? Well, set interval returns a handler or a reference, Set internal returns a reference, and this reference will be used so I can stop it after it has been executed. So let's define this reference here. Let's say internal reference. Internal reference we are going to get that value, this internal reference, sorry, interval. I want to call it interval reference. Yes. Naming is hard. So I'm storing the reference of that specific timer, and when I stop, I will clear that interval reference. So it will stop the timer. Last but not least, what we need to do is define the isRunning variable. So when I start the timer, isRunning equals true, and when I stop the interval, isRunning equals false. So let me deploy. If I want to make this code safer, what I can do is check if I already have an interval reference done started, and if I don't have it, don't try to stop it. Pretty much having an if to check if the interval reference exists before executing the methods, but we can leave it like that. Like that is going to work. Okay. Hey, Hector Saldaña submitted the following question. Is there a repo where I can find this codeLive example? Yes, I will be uploading this code to GitHub, and I owe you the previous code. So whoever is moderating this chat, I hope is Sarah right now, I will give you the links so we can update the descriptions of the video so you have access to this code. But yes, I will put the source code out there. Awesome. So I refresh. Let's see if the interval works. The interval works. I start, and now it is counting. 1, 2, 3, 4. I stop, and let's put it faster. Now it's faster, and I can have it more fast. Oh yes. You can see that now I can change the interval value and it will iterate faster. What I can do is, okay, maybe when I do a stop, I can reset the counter or put it to 0 or something. Okay. Can we use set timeout inside for loop for each iteration? What is the use case for that? Because what's going to happen is the for loop is a synchronous operation, but set timeout is going to be asynchronous. So you are going to schedule a lot, or depending on the number of operations you are going to perform, a lot of different asynchronous operations inside a for loop. And second, if you rely on the index, if you are going to pass that incrementer value or the I when we use the for loop into the function, there might be a problem there, because when you define the function, it will be always at the first value and not the value that is updated. That's a very good use case, and I will keep it there, sort of, because I have limited time. Remember, after I finish the cars example, so we can do some live coding to see what problem can I have by executing set timeout on a for loop, okay? Remember, after I finish the car, so we can cover all of the examples without losing a lot of time, and I will show you the problems we can face and how to solve them, okay? Awesome. Let's learn about promises and async away. I will change to the movies component. For the movies component, I created an HTML which has a data table and a button. And the button is going to execute the get movies function. And get movies has the is loading and is loading true and is loading false. And I need to perform an asynchronous operation here. We will fetch information from the web. So we are going to perform an I/O, an input and output operation. This is also an asynchronous operation, and we will use fetch, which is the HTTP client for JavaScript. We are going to this API, we are getting the data, and this request will take time. So depending on the amount of data or what I do with the data before, after, we are not going to take the data immediately, so this is asynchronous. I will need to do this asynchronously. So fetch is a method that returns a promise. We can see here that this method returns a promise. And the promise is of type response. So when I fulfill the promise, I get a response. But Julian, what is a promise? A promise is a way to execute the asynchronous operations. JavaScript is telling me, I promise that I will give you a result in the future. In other languages, this is also called futures. So I will give you a response, or I will give you a result in the future. I promise you that. And a promise can have 3 different status. Pending, which is I don't know yet about the result of this operation. I'm waiting. Is pending. Fulfilled, which is I succeed, I got the value, here is your value, and rejected. And rejected is what we don't want. I wasn't able to fulfill this operation, I failed, this is the error why I failed. I will give you this documentation, which is from the Mozilla Developer Network, the best way to learn about JavaScript. And you can see that you have the 3 states: pending, fulfilled, and rejected. And a graphic pretty much showing you how can you work with promises. So when a promise fulfilled, I can get the result by using the then method. And if it fails, I can get the rejection by using the catch or by passing a second argument to then. Okay? Let's see the example. So I'm going to perform a fetch operation, and if it is successful, I will execute a function, and if it fails, I will execute a function that is going to handle the error. So this is the logic that I'm going to be following here. So fetch, then I get the result, and if it fails, I will get the error. So what we are fetching is an API. So I already have an API URL variable here. So I am passing the route. Remember that we already covered this in previous live code, in codeLives. Go take a look at YouTube so you can see when we cover this topic. So I will get the movies. And then here, again, I will use arrow functions because I will need the context of my component to process the data. I am getting the response. Now here I have the response. So what I do with the response? Well, I can check the status code. I can see if the server responded with a 200 or a 500, depending on what we want to do here. And also, I can process pretty much this response. I know that my API, the movies API, returns a JSON. And response, let's take a look, has a JSON method that is also a promise of any type. This doesn't know about what type I'm going to return you, but it is also a promise. So you can return a promise on this promise chain, and you can get like another opportunity to get that value. This is why it's called as thenables or as promise chains. So pretty much what I'm doing here is, okay, return this promise, this JSON promise, so I can capture that value here. So now I captured the JSON value from this operation. So I'm returning this promise and I'm resolving this promise here. And now I have data. And this data is the data that I want to assign to my variable, to the data property on my component. So this data equals JSON. And what happens if there is an error? I will receive an error object, and I can't do anything with this error. Right now, let's just print it out on the console. But the best way of handling this is obviously with a toast or responding the error back to the user so the user knows that something failed. What do we do with this loading? Well, promises have also had like a finally method. And this finally is a step that is going to be executed always after a promise has been either resolved or rejected. And I will pass the is loading to the finally method here. Okay, let's review. I am fetching the data, then I'm getting the response as JSON, then I am resolving that JSON promise using a promise chain, assigning this to my data property here in my component so it can be rendered. If there is an error, I'm going to be printing the error. If there is no error, nothing happens. And finally, I'm going to set loading as false. Going back to the chat, I see a lot of actions. Can we do a small LWC real-time project? Nailish, stay tuned. Next week, I will be working with real-time, WebSockets and EMP API. Ike, glad you like it. Async await is king to avoid callback hell, and we will transform this code using async await. Give me a moment. Hector, Julian, which method is safer? Create a callout by using the fetch operation or by calling a controller Apex method with the future annotation? Speaking Salesforce security. Hector, if the API has security credentials, Apex. With named credentials, that's the way to go. If you are calling an API that doesn't require any security authentication like this one, you can do it from Lightning Web Components without an issue. There is no security risk. But if you have credentials, like API tokens or outflows or something like that, go Apex. Ike, I have an API request I need to make and it uses auth0 as authentication and authorization. I add the auth information into auth provider section, but it doesn't not give you option to put audience. Is this on named credential, Ike? I have not worked with auth0 with Apex, but you can maybe send me a DM on Twitter and we can research after this. Let's see if this works. I push this code because obviously we have 22 minutes left and I still have a lot of ground to cover. Cool. Let's deploy. It works. Refresh. And let's load movies. So load movies. And there we have. It went, fetched the movies from the API, got the movies, rendered the component, and you see that the load button gets disabled and enabled after it gets the data. So promises is working. We can improve this, obviously, if the response is not okay. We can throw a new error, and this error will be captured here on the catch, but let's not go there. How can we turn this into async await? We can do the following. First, did you know that methods in LWC can be asynchronous? So you can add the asynchronous keyword here. Also, with async await, pretty much you are executing the functions as if they were synchronous, but they are not. It looks like I have a synchronous flow or a sequential flow, but they are doing asynchronous operations. So here I get the response by awaiting the fetch. Then I can get the JSON by awaiting the response. And last but not least, I can add the data of the JSON pretty much variable that we got here. So we simplify all of that code into these 3 lines. But what happens with errors now that I'm working on async await? Okay, I'm going to be doing something. Sorry. Let me go back, because I know you, when I push this code, you want to have both, right? So let me copy this method. And I have async get movies. This is way better. Res await. So we have the 2 things. Const JSON await res.json, and this data equal JSON. Let me do this and do that. Okay, so now I simplify this operation. But how to handle errors? Well, if we are using async await, the best way to handle errors is by using try catch. If you come from Apex background, Java background, try catch is going to be familiar to you. So let's pretty much do this. Move this code into the try. So I'm going to try to perform this operation. If there is an error, I'm going to log the error on my terminal, and I can also use finally on the try catch. So this try catch at the end of all of the operations, depending on if it succeeds or fails, it will execute the finally. And this is get movies async. I will change it here. Get movies async. Let's deploy, and let's take a look at questions. Wow, have a lot. Awesome, load the content, beautiful, transforming into async await. Try catch is needed this time. Yes, try catch is needed. You learn to love it. Fantastic. Now refresh, and this should behave exactly the same. Load movies, and I get the movies. Now I'm using async await. There is another thing that I want to show you, which is how can I use a custom promise to transform asynchronous code into a promise. Let's create a function called sleep. I will call a function called sleep. So sleep receives a time in milliseconds, right? So you guess we are going to use set timeout. And pretty much what I want to do is do a set timeout and wait that amount of milliseconds and then continue the execution. But how can I do that? Well, I can use promises here. So what I will do is wrap the set timeout into a promise. This is a pattern that you are going to find a lot in JavaScript. So you can return a new promise. So now we are creating an instance of a promise. And the constructor of a promise receives two functions. One function receives one function with two parameters. One parameter called resolve, which is a function, and one parameter called reject, which is another function. So resolve and reject. Remember that I told you that promises have three states: pending, fulfilled, and rejected. Well, resolve is going to fulfill a function and reject is going to reject a function. So what I will do here is wrap the set timeout. So set timeout has a function that I will be executing after certain time. Okay? And what function will be executed here? Resolve. And I can pass a value into resolve if I am wrapping something that is returning information, but this time I don't need it. And also I'm doing like a double wrapping functions here. If set timeout receive a function, I just can simplify this by just passing the resolve. I don't need the reject, so I can remove this. But if for some reason you want to have like a error path, you can use reject to reject the function. So now I created a sleep promise-based function that I can use with async await. I can do something like await this sleep 2000 milliseconds. So I created a asynchronous function by wrapping a promise. And now if I deploy this, now it will try to fetch the API after 2 seconds. How powerful is this? I mean, you can wrap any asynchronous operation within a promise by using the promise constructor. Now let me see if this works. Movies, load movies, 1, 2, and go. We have it. Love it. Questions. What is the value for the API URL? It is add under trusted sites? Sadly, we don't have access to trusted sites from LWC, but I defined it as a constant on my component. You can find it here. It's as a constant. Cool. We learned about promises. Now let's go to learn about concurrency operations that I can do with promises. Okay. So we will go to the cars example. So now remember that I have two different APIs and we are running out of time. So we have cars large, which has like 1,000 cars. And we have a way to crash the cars API by passing this parameter. Okay? So let me create 3 methods. So these 3 methods are going to be get, no, let's call it fetch cars. The other one is fetch cars large, and the other one is fetch cars error. So we have 3 methods, right? Those 3 methods are going to perform an API operation. Well, let's simplify this. I am not going to be designing. This can be better code. I promise you it can be better code, but let's do it like a quick copy paste. So const res equals await fetch. And I am not going to be handling errors. So sorry about that. but you are better developers than me. You are going to be handling errors. Now the JSON, I get the response. Fantastic. And I return the cars. And I will be copying this. I know I am repeating code, but this can be improved. This is just to prove a point. And this is cars, boom, equals true. I have 3 different asynchronous operations. These return a promise. So every asynchronous operation return a promise. So you can use either async await or you can use then if you want to execute this asynchronous function. Okay? So now let's get the cars. Well, we are going to see some methods that are for concurrency. One method is called promise any. Promise any takes an array of promises and returns the function that is faster. Okay? So I'm going to be borrowing sleep from movies because we will use it here. We will use it here. So get the sleep. I like it. And let's add it here because we will use this thing. Okay. Cool. So let's do my first asynchronous operation. So far, I am not going to be binding the data. I just want to prove a point here. So let's use promise any. So let's get the response is only one value, right? It's equals await promise any, and I need to pass an array of asynchronous operations. In this case, one is going to be this sleep 50. The other one is going to be fetch cars. And the other one is going to be fetch cars large. I'm not going to be using the one that crashes. And at the end, I'm going to console log the response. And let's modify sleep so we respond with something. So we get a value. This is hello from sleep. Cool. Let's deploy and see what happens. So any promise any is going to execute the promises and returns the fastest. It doesn't care. It will give me the fastest value. This is very useful, for example, if you have redundant data and you just need the one that gets faster to you. Maybe you have 3 APIs that returns the same data or perform the same transformation, but you just need the one that gives you the result faster. You can use promise any to get that operation. Let's go. Refresh. Let me see. Okay. As we know, Lightning record edit form on load method called multiple times until the form get whole data. So can we implement async await on load method? I think so. Is async and await synchronous code running on main thread? It is not synchronous. It is asynchronous. It's using something called the micro task queue. So it is queuing data in the event loop as well. What exact difference between promises versus async await? Promises and async await are the same thing. Async await is just syntactic sugar or a better syntax to operate over promises. But they are the same things. Underline is the same thing. Cars. Let's continue. Let's load cars and see which one is faster. What do we get here? Load cars. Hello from sleep. Sleep is fast. Why? It takes 50 milliseconds. It's faster than any network operation. If I add this as, okay, take 5 seconds to finalize, it will try to fetch either the cars or the cars large. And let me go ahead. Get this. Load cars, and it gives me get cars, which is the one that has 100 records. If you can see here, I have the cars, which are the 100 records. So that's the first one. Promise any. It doesn't care about which one is going to give you. It will give you the one as soon as possible. Okay? If any one fail, it will ignore it in this case. Okay? Then we have promise raise. This is also similar to the other method, but this one is going to resolve both promises, but is going to return the one that is pretty much faster as well. But if one fails, we will have an error here. So raise is going to perform pretty much the same as the other, but ones ignore errors and this one takes care of errors, so we will need to do a try catch. The other one is all. All executes all of the promises in that array and returns all of those values. But also, if one of the promises fails, it will reject the whole operation. So let's take a look. Now we don't need the sleep. Let's execute all. And this is going to respond with two values. So cars and cars large. So I can print both objects, cars and cars large. Let me deploy. So in this case, I am executing all the promises and I'm assigning the first execution to the variable cars and the second execution to cars large. So this returns an array with the values. If I have 3, I will return an array with 3, etc. This is what it's called in JavaScript object destructuring. I am doing an array destructuring here to get those values. Let me do this really quick, running out of time. Execute the cars, load cars, and you see that I have the two objects here. One with 100 and the other one with 1,000. But what happens if I introduce this fetch cars error into the equation? And I have a value here, cars error. What happened here? What do you think? Let me deploy. So now I have a function that fails, that it's going to throw an error. Or, well, this is not going to throw an error because it will give me a JSON file. So let me see. These changes on the org with the local you are trying to deploy. Conflict. Let me see why it is not deploying. There are changes in the org that conflict with the changes you are trying to deploy. Let me try to force. Can I force? It doesn't exist. I think force is different on this. Give me a moment because something happened that now it is not letting me deploy this. What is for? R, ignore errors. No, R, ignore errors is not forcing. I think ignore errors. R, let me see. Yes, promise all the time. There is another one which is all settled, which is better than promise all. Okay, this is good. This is good. I don't know why it is not letting me deploy just at the end of the stream. Now when I don't have time to show the thing that I had last. Cars.js meta? Did I change something here? No. SF metadata retrieve. Let me try this. If not, I will need to stop right now because I'm running out of time, or pretty much I ran out of time. No, I have a conflict. SFDX force source push U LWC async scratch force. Let me see if I can override. Last try. I'm sorry about this. I was not expecting an error. Okay. It deployed. Let me refresh. I am introducing an error. The thing is that I am not throwing. Now that I know I am not throwing, I just need to modify a couple things. So if I load cars, I get error, something happened. Yes, because I am returning a value. I am returning a value, but I am not crashing. I am not throwing the error. So what I do here is the following. If resp is not okay, throw new error, boom. Now this will crash. Let me force override. I have time to finish this. Oh, thank you very much. So let me try if this works. If this works, I will be super happy. And now, let's see if this work. Load cars. And now I have a real error. Uncaught promise exception. What does this mean? That now this operation that I'm doing here needs to be surrounded by a try catch. And if something happened, I will need to obviously print out the error that happened. Okay? So let me do the try catch. Something happened. And if something happened, I'm going to be printing out that error. If it is good, I have the other ones. So for the other ones, let's say that I'm going to be assigning data or cars to data, and I'm ignoring the others. Okay, so I think this is it. This is what I wanted to show you. The other method, and I will give you so you can investigate it, is all settled. All settled, it will succeed independently of if a promise failed or was fulfilled. But what it returns is a value or a property that has three different values. A status, that it will tell you if the promise was fulfilled or rejected. Value, which contains the response. In this case, only appears if the promise was fulfilled. And reason, it will give you the error in the case that promise was rejected. So you can execute multiple promises and then iterate over the values to get the ones that you wanna have, for example. And this pretty much will show me an error here in the console. Now this is printing out the error object, but it's getting handled. And let's remove the thing that it's failing because I want to see data. We haven't seen data yet. So I'm going to execute all of the promises, but I am just getting the cars and I will be adding the cars to the data table. And that's it for now. I am 5 minutes after the hour. Load cars, and now I have the list of cars loaded on my data table. This is great. Fantastic. Thank you very much for joining me on this codeLive. I hope you learned some JavaScript tricks with async await, how to wrap a synchronous operation with a promise, how to work with timers, how to use the different concurrent methods with promises. We will keep using these in future codeLives. Join me next week. We are going to be doing asynchronous Lightning Web Components using EMP API, and WebSockets. So we will connect to a WebSocket server in Heroku, and we will get in real-time data, which is also asynchronous. Thank you very much for joining me, for being with me here in this hour, and see you on the next one. Bye-bye.